right, so we're doing 5.5 exponential and logarithmic equations, or solving exponential and logarithmic equations. So if I wanted to solve this, right here, what would I do? Well, I could also rewrite this as a log equation. Log of 3, so log base 3 of 5 is equal to x, right? So I can rewrite this as a log equation. So log 3 of 5 of x, so I can solve for x, because I want to know what 5 raised to what power, or 3 raised to what power is 5, right? That's literally what I'm asking here. And so in order to solve this exponential equation, I'm going to be using logs, because this is something I can just crunch through a computer, right? In the old days, we used to write ln of 5 over ln of 3, but now we actually can compute this directly using our calculators, right? So we can just use a calculator to compute this directly. So x is equal to 1.1 or 46. I've already calculated it. And so here's how we would solve it directly. If I wanted to solve this directly, I could do this. But there's also another way. And so let me show you the other way real quick. And that's what we're actually going to be doing. So here, if I have log of 3 of x equals to 5, one of the things I'm allowed to do is take a log of both sides. So if I take log of, if a equals b, then the log base c of a is equal to the log base c of b, right? This is something, I don't know if I explicitly told you this or not, but this is the theory we're going to be using the whole time, basically. So I'm going to take the log of both sides. And so one of the things I'm allowed to do is take a log of both sides. So log base 3 of x is equal to the log base 3 of 5. And so log base 3 of x, well, this just evaluates to be x, right? And here we have log base 3 of 5. Okay. And so this gives us the same answer. And so that's really what we're going to be doing. It says if I was going to solve this directly, I'd just rewrite it as a log equation and solve. But if given an expression, no matter what it is, I can always just take a log of both sides. That's a valid thing to do. If a equals b, then log base c of a is equal to log base c of b. And so that allows me to taking a log of both sides an allowable operation. So here's our little steps. We're gonna first isolate the exponential to one side of the equation. 2, we're gonna take the logarithm to remove the exponential. And 3, we're gonna solve for a given variable. All right, so here, let's see how this works in action. So here, notice here that unlike this one, which is simple and I can just rewrite it as a log equation and solve for it, right? Here, I'm going to get something different. And so let me show you the steps. So here, the first thing I'm going to want to do is take log base 4. And the reason I want to take 4 is that's because of what my exponent is. My exponent's a 4. So 4 base of x minus 2 equals log base 4 of 15. The log base 4 of 4x minus 2, if you remember from our little rules, is just x minus 2. Log base 4 of 15, well, that, whatever it is, it's just some number I can crunch in a calculator, right? I can just crunch whatever that number is in the calculator. So that's some number. And then the thing I'm going to do is solve for my variables. So step 1. All right, so step 1 was already done for us in this case. Step 2, we took the log of both sides. Step 3, we solved for our variable. Log base 4 of 15 plus 2. And here, let me open up Wolfram Alpha. And I'll show you how to type it. I'll get to Gina. There you go. I gotcha. All right, so let's open up Wolfram Alpha. All right, so log base. So we're going to type in log underscore 4 of 15 plus 2, because that's what we solved for. And here we get it's equal to roughly 3.95. So we'll just write in 3.95. Okay, and we can also check it. So even though we've done all that, let me just show you once how to type it in. So here, Wolfram Alpha is super smart. And so if you just typed in 4 to the x minus 2 equals 15. Gee, can I see the approximate form? Yeah, see 3.95, right? So it knows how to just compute it directly. Okay, and so here, how it solved it was a little bit different. It just split the exponent and then solved for it. I mean, that's another option. But we're always just going to solve it this way, so you'll have a very formulaic way of solving it. Okay. All right, so that's the first one. So let's do the next one. I'm going to do a couple, and then I'll have you guys try one. This one that's really kind of weird that your book may throw at you or may not. I just want to make sure you've seen it. All right, let me clear this up just oh no, I was on the wrong layer. Fine. Go on, back. Base 4, 15 plus 2 is equal to 3.95. There we go. All right, so here we have 5x. So our first step is just to get 5e to the 4x minus 10 equals 45. So our first step is to get the exponent by itself. So we're going to add 10 to both sides. So I have 55. We're going to divide by 5. So e to the 4x equals 11. Can you explain how I got the 3.95? Oh yeah, I just typed this in a calculator. That's how I got it. Log base 4 of 15 is just some number, right? In fact, that number is 1.95, right? It's just 1.95. So log base 4 of 15, it's a number we just crunch in a calculator, okay? So we just crunch this number in the calculator, we get 1.95, and then we just add 2 to it, since x minus 2 equals log base 4 of 15. So I add 2 to it, and then I get 3.95. Does that make sense how I got that? Okay, yeah. So log base of something, of a number to a number, is a number. You just don't know what that number is, right? Until you crunch it to a calculator. Okay. All right, so here, we're going to move the 10 over. We're going to divide by the 5. And so now I have the exponent. So now I've isolated the exponent to one side of the equation. Okay. The next thing is take the log to remove the exponential. So here, the log I will use is natural log. So natural log of e to the 4x is equal to ln of 11. So this ends up being 4x equals ln 11. Remember, ln 11 is just some number. That means x is equal to ln of 11, so natural log of 11, divided by 4. And here, if we just crunch this through a calculator, I'll crunch a couple more through the calculator so you can see what I'm typing in. But after that, I'm going to just tell you what the numbers are because I've already pre-calculated it. Oops. I wrote a 2. I should have wrote a 4. So here we just have natural log of 11. So ln is natural log 11. Remember, Wolfram Alpha says if it's log with nothing, it thinks it's log base e. And so here I get 0.599, so just 0.6 roughly, right? So x is approximately 0.60 roughly. All right. So let me show you a couple other tricks. So I'm gonna do C. I'm gonna have you guys kind of work on D for a second, and then we'll do the other two together. All right, so here we need to get the exponent isolated on one side. And so in order to do that, I'm going to write pi of x plus 3. So remember, if I have pi to the x plus pi to the 3, multiplied by pi to the third power, that's, you can add up the exponents. And then once I add it, hit mute for our friend. So here we've combined it. In this case, I'm just adding up exponent using my exponent rules. Okay. Second thing I want to do is take log base pi. So whatever this exponent is, that's what we're going to use. So log base pi of x plus 3 equals log base pi of 30. Log base pi, oops, hold on, I wrote this wrong. Log base pi of pi to x to the third. Now the reason we always use whatever the base is because this cancels each other. And then here I have log base pi of 30, and then so v equals, so x is equal to log base pi of 30 minus 3. I crunch that through a calculator, and that's going to equal to minus 0.03. All right, so with that in mind, go ahead and attempt to do D. Go ahead and attempt to do this one and see if you guys get an answer. And if you get stuck, let me know where you get stuck. Okay, so give that one a try. I'll give you guys about a minute or two to work on it, and I'm going to go grab me some water. So give it a try. Oh, can I CC? Sure, I can. Let me move it so you can see stuff. There you go. All right. Did anyone get an answer or close to an answer? Is anyone alive? Oh, we got someone with an answer. We got one answer. Maybe if we get another one, we'll go ahead and go through it. Oh, we got two. Okay. All right, so let's crunch through it. So here, we need to get this as a singleton. So remember, if we have an exponent raised to an exponent, it's the same thing as multiplying the exponent. So this is 3x equal to 15. So that's our first step. Our second step is we're going to take the natural log of both sides. This, of course, cancels, so I have 3x equal to ln of 15, and then we're going to solve for x. And so that's just x equals to ln of 15 over 3. And, that was the answer you guys gave in chat. So that's really good. Just I didn't crunch out what that number was. I lied. I said I pre-crunched most of the numbers. Guess who's a liar? Let's just do that real quick. If your book wants it in precise format, I know I didn't look at the homework. We'll look at it at the end of the day. If it wants it in precise format, just give it this, or write ln, right? And if it wants it as not precise, decimal points, just do this. So it's about 0.90. Okay. All right, so now I'm going to show you the two, what I call the hard versions, right? But so both of these are hard. But once you know how to do them, you can just follow the same function, same form and function, which I'm doing here with you. So the first one looks something like this. It's like, oh my goodness, how am I going to solve this, right? It's not in the same, it's not the same format, not same anything or anything. So what you do is it's just another one of those u substitution, the book says, and so e to the x is u, and so this is u squared minus u minus 6 equals to 0. You factor that, you get u minus 3, u plus 2, or oops, I forgot the u, didn't I? U plus 2 equal to 0. And that means either, and then you just plug it back in, that means either e to the x minus 3 equal to 0, or e to the x minus or plus 2 equal to 0. And then you just solve for it, right? So here we have e to the x equals 3, and we have e to the x equal to minus 2. Notice that this cannot occur. E to the x can never be negative, right? So this cannot occur, so you only have to solve this one. And then solving this one gives you the following answer. Wasn't this the one we solved way up front? No. Okay. Well, here we have e to the x. So here we just take ln of e to the x. Ln of 3, that means x equals ln of 3. Okay. And so if you see anything that looks like this, books randomly like to put it in for who knows what reason. It's just they want to get you very used. You know, your book did this before with like, you know, you had x to the 4th minus x squared minus 6 equal to 0, or you had x minus square root of x minus 6 equal to 0. It just likes to do this little game where you do the substitution. So if you see some exponential and then 2 times that exponential, just use this u substitution, factor it. Okay. So that's if you see that. And the other one's a little bit more popular. I'm just going to erase that right here for a second. There we go. All right, and this is where you have an exponential equation with two different bases. So here I have a base of 7 and a base of 3. So if I chose log base 7, this one would be 2x, but this would be still kind of a mess, right? If I chose log base 3, this one would be just x plus 2, but this one would be a mess. And so in this case, it really doesn't matter which log you use whatsoever, right? And because I'll teach you how to do it. And just to make sure you know how to do it, regardless what base we're going to choose, I'm going to choose ln. And so in this case, if you have two different things, you're just going to take ln of both sides. So 7 to the 2x equals ln of 3 to the 2x. So you just take the natural log, right? And the reason I take the natural log, it's the shortest to write. That's why. It's 2 characters instead of 4. And so then we're going to use the rule that exponents become multiplication. So this is 2x ln of 7 equals x plus 2 ln of 3. And so we're using this exponent rule like we did in 5.4. And so once we use this exponent rule here, we can solve for this. Remember, ln of 7 is nothing more than a number. It's nothing more than a number. Because here we can just type in ln of 7, right? So ln of 7 is nothing more than 1.94, right, roughly. And then ln of 3 is nothing more than 1.09. So even though we're going to leave it, thank you, even though we're going to leave this as ln of 7, this is just a number, right? And this is just a number. And so we're going to solve it as if it was just a boring number. And how do we do that? Well, we just say, so we'll just distribute it in. So here I'll have 2 ln of 7x is equal to ln of 3x plus 2 ln of 3. So I'm just distributing this over, and I'm putting all the constants together. Then I'm going to minus, I'm going to have x on this side, have x on this side, so I'm going to just minus out. So I'm going to have 2 ln of x minus ln of 3 of x is equal to 2 ln 3. Here I can factor out an x, so I have x equals 2 ln 7 minus ln of 3 equals to 2 ln 3. And then I can just say x is equal to 2 ln 3 over 2 ln 7 minus ln of 3. And then if I wanted to, I can roughly crunch that in a calculator, and you're going to get 0.78. As long as you remember that this is just some number, right? It's just some number, right? It's kind of a long number, so we're just going to leave it as ln of 3, and this is some number, and this is just some number. They're just constants, right? This is constant, this is constant, this is constant. So it might look awful to solve, but it's just constants, okay? So I'll leave this up for a second so you can copy it down. We'll answer probably some of these maybe later this week if we have a little time. So, all right, let's get to our next page. I know this is only 2 pages of notes, but it's kind of a long set of 2 pages of notes, if that makes sense. Because I want to just have you see a lot of examples of what could go on. All right, so let's do the next set. All right, so here, if I want to solve log base 3 of x minus 2 equals to 2, well, here if we have a equals to b, then e, or then c to the a is equal to c to the b, right? So once again, we're allowed to exponentiate. So as much as we're allowed to take logs of both sides, we're allowed to exponentiate both sides. So here, I'm going to raise both sides to the power of 3. So we're going to have 3 log base 3 of x minus 2 equals 3 to the 2. And so 3 log base 3 of x minus 2 is just x minus 2. So what it means, because since these two functions are inverses, right? And then 3 to the 2 is just 9. So x is equal to 11. So I'll add 2 to both sides. So x is equal to 11. And so that's how we're going to, oops, I should say log. It should say log equation. Isolate the log to both sides. I copied and pasted, as you can tell, and didn't fix it. All right. So here, we're going to isolate the log to one side of the equation. We're going to take an exponential to remove the logarithm. At least hold on. Yeah, take the logarithm. Yeah, at least I remember to swap that. Solve for a given variable. And then check your answers are allowed. Basically, check your domain, right? Make sure you don't have any logs which are negative. So no negative logs. All right, this is important. Okay. It is important. Kind of like when we solved, what did we do? We did square root equations. Remember how you can get answers? So it doesn't matter. So on for number 7, it doesn't matter what log you use whatsoever, right? Because you're just going to be using the log to pull out the exponents instead of clearing. So here we use logs to clear, right? We use it to clear and you just got x minus 2, right? Since we're only using it to move the exponents out, it doesn't matter. I could have taken log of 2000 for all I cared, right? And log base 2000. So in this case, it doesn't matter. Okay. All right. So yeah, so here, no negative log. So remember when we did square roots, we could produce answers that weren't in our domain. The same thing's true for here. When we're solving for logs, we may produce x's that are not in our domain. So we just need to be careful. And I think I have one. I make sure I can do one. Yeah. So yeah, we'll there at least one of these. I'll show you something can't happen. Okay. All right. So let's go do this. I'll go back to blue. All right. So here, so we're going to isolate the log to one side. This is already done. The log's on one side. So the first thing I'm going to do is exponentiate both sides to the power of 5. Whatever the log base 5 is, that's what we're going to raise to both sides to the power of. So it'll be log base of 13 minus x equals to 5 squared. Log base 5 raised to log base 5 is just whatever's in here. That's what we did with our log rules forever last week. And this is just 25. So this is minus x is equal to 12. Move over the 13. And then x is equal to minus 12. And so this is 2. This is 3. All right, now we need to do 4. 4 is the check. And so here we just plug in 12. So we have log of 5 of 13 minus a negative 12 equals to 2. And notice here that log base, this ends up being log of 5 of 25, right? Which is 2, which is okay, right? Because this is positive, and in fact, this does check our answer, right? Not only is the answer allowed, it's easy to see that 5 raised to what power is 25? Well, 2, right? And so this ends up not being negative. So let me show you where it breaks. So let's do this one. Oops, let me clean this up just a teeny bit. All right, so let's do this one. So if we have this, what are we going to do? Well, we need to isolate the log to one side. So if we have them as additions, we can put them together as multiplication on the inside, right? Equal to 1. Here we're assuming, and your book always assumes log of nothing is log base 10, in case you forgot. So we're going to exponentiate. So the second step is we're going to exponentiate both sides to 10. So we log of 10, log of x plus 2, x minus 1 is equal to 1. Or 10 to the 1, because we need to exponentiate both sides. So these will cancel each other, and we get x plus 2 times x minus 1 equal to 10. And then we're going to solve. Okay, so in step 3, we're going to solve this. Please, 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 you're going to be super tempted to do this. Either x plus 2 is 10 or x minus 1 is equal to 10. Do not do this, right? It only works if this is 0, right? The zero multiplication rule says either this is 0 or this is 0. This is not 0. That does not mean this was 10 or this is 10. I say this because you guys know this, but when you're working with logs, you just get to this point. You're so focused on the log, you forget the basic stuff, right? It's like when sometimes you're like so focused on something super important, you just miss your exit. It's like, oh, I should have taken that, right? While you're driving. So go ahead and expand this out. Go back to A, please. You have a question on it? Or you just want to see it so you can write it down? So once you get to this point, go ahead and expand it out. So you'll have x squared plus x minus 2 is equal to 10. Move the 10 over, you'll have x squared plus x minus 12 equal to 10, or equal to 0. I move 10 over. Refactor it, you'll have x plus 4, x minus 3. All right, and so here we get the two factors. Here we're going to get, let me give myself a little space right here. So we have x equal to minus 4. We have x equal to positive 3. X equal to positive 3 is pretty safe, right? I mean, because here when we plug this in, and so technically what you need to do is just plug this into here. So we have log of minus 4 plus 2. But notice the second we start plugging this in, so when we start plugging it in, so here I'll have log of minus 2. This cannot happen, right? We can't have negative logs, right? No negative logs are allowed. So this is not an answer. So this is not an answer. Here, if we plug this in, here we have log of n of 3 plus 2 plus log of 3 minus 1. Notice that this is positive and this is positive, so this is okay, this is okay, so this is our answer, okay? So once again, you have to be very, very careful. So if you get a negative log from your x when you plug it in, you have to throw that one away, right? You just have to throw it away. Because we cannot have negative logs. I'm going to rephrase that. Up to anything you guys are ever going to do in your lifetime, you won't have negative logs. Now, can mathematicians do funny stuff later in life? Sure, they always figure out how to do stuff really funny with complex numbers, right? But for now, okay. All right, so I'm going to zoom out just a teeny bit. All right, so go ahead and try C. Go ahead and give C a try on your own and see where you get. And then I will do D with you. Okay, so try C. Let me move this up just a little bit. So remember, first, isolate the logarithm. There's a lot of things you can do right here to get the log by itself, so do that. My dogs are snoring. And then just exponentiate both sides. This time will be log exponentiation to the 4. And then solve for the variable. And this one clearly is okay when you get to the end. Sorry. One double head. Pup, you're distracting the class. They see you. Got double breath. I'm gonna have to brush them later tonight. Yeah, second you guys get an answer, just put it into chat. And if you get stuck at some point, kind of tell me where you get stuck at. This is why I miss teaching live, because as you guys work on it, I kind of wander around. It's like if you don't know what the next step is, ask me and I'll walk you the next step. But it's kind of hard over Zoom. Anyone get it? All right, does anyone have an answer? Yeah, super white cubism. No. It's kind of confusing me. Okay, so let's move you a couple steps forward and see if you can go from there. Okay. All right. All right, did anyone isolate the log? So if we're going to isolate the log, let's kind of work through this. What would be the first thing I would do here? Let's see if we can work it through at least together. So I want to get the log by itself. So the first thing I would do would be what? Move over what? The 3. Yeah, so move over the 3. So here we have 2 log of 4 of x minus 3 equals 8. All right, so minus 3 from both sides. And so what's the next step we want to do? We still want to get the log by itself, so I can get rid of the 2, right? So I can divide both sides by 2, right? So I have log of x minus 3 equals 4. Okay. Everyone, did you guys get to this step? Was this where you got lost? Kind of let me know which step you got lost on. Yeah, so most people got to this step. All right, so we got to this step. All right, so what's the next step? Next step is to take an exponential to remove the log. So now we want to remove. So I'm going to raise both sides to what power? What power am I raising both sides to here? To remove this log, I want to remove the log base 4. What do I raise both to what power? Or exponentiate? What's the base of what I'm exponentiating? 4. Yeah, 4 is correct, right? Because here I have log of 4. So I have 4 log of 4 of x minus 3 equals 4 to the 4th, which is 256. Okay. So we have 4 to 4. So remember that a of log base a of x is equal to x, right? That's how it's written in your happiness. So here, if I have 4 log base 4 of x minus 3, well, that's just x minus 3. Okay, so x minus 3 equals 256. And that just means x is equal to 259. Yeah. Okay. So let me just put little. I guess I have 1. Let's have 1.1. This is 2. And this is 3. This is 3.1. So which step are you guys getting stuck on? If this is the first step, second part of the first step, second step, third step or 3? Which one? The first? Oh, okay. Yeah. Here you just try to pretend like this is some y and just try to clear everything. 2. All right. So yeah, one thing. Well, no matter what the log is for these, it's always just exponentiate to that power, right? So here is log base 5. So you just take 5 to both powers, and then log base 5 is just whatever here drops down, right? Here we had 10. So this is log base 10. Whatever's here just drops down. Here we had log base 4. So we exponentiate to 4 to both sides, and whatever is here just drops down, okay? Honestly, I thought I did something wrong. Seems like too big of a number. No, sometimes when you solve for logs, you get really big numbers. This is safely not negative. If I plug this in here, no log is negative, right? And so step 4, check, we're good, right? You're going to get funny numbers. You've worked with this computer system before. You're going to get funny numbers. All right, so let me show you one trick here with this one, and we'll look through the homework real quick afterwards, and we'll call it a day. All right, so here I have log base 2 of x plus 2 to the third power, right? So in this case, my log is technically isolated, right? I technically have all my log right here. Okay, I mean, that's technically true. But notice here, I can make my life a little bit simpler by dealing with this exponent. I could have 3 log base of x plus 2 is equal to 9. And then I can divide out the 3, and so I get log base 2 of x plus 2 equal to 3. And notice here, I've gone from a cubic function I'll have to solve just to a normal function. So this is one of the cute little tricks I just wanted to show you. Here, we're going to take, so this is step 1. So step 2, I'm going to exponentiate both sides of this to what power? What power am I exponentiating to? For B? 2. Yeah, 2 is correct. And so here I have 2 log base 2 of x plus 2 equals to 2 to the third power. That means x plus 2, because whatever is here just falls through when you have 2 to, if you have a raised to the log of base a, so 2 raised to the log base 2, whatever's there just drops down. And then here, 2 to the third is 8. So x is equal to 6. We plug that back into here, we get 6 plus 2 raised to the third power, and that is correct, right? So, so this one checks out. So step 4 checks, okay? All right, so let's just open up the homework for 5 minutes, just so you can we'll flip through it real quick, just so you have a clue of what's going on.